Definitions of the term landslide include: landslide is a general term, which refers to a variety of mass movement processes, in which material is transported downslope under the pull of gravity. Landslides are a type of mass wasting, which denotes any downslope movement of soil and rock under the direct influence of gravity. A landslide is any geologic process in which gravity causes rock, soil, artificial fill, or a combination of the three to move down a slope. Landslides are part of a more general erosion or surficial process known as mass wasting, which is simply the downslope movement of earth or surface materials due to gravity. The term landslide encompasses 5 different modes of slope movement: falls, topples, slides, rotational and translational, lateral spreads, flows. The aforementioned landslide types are further subdivided based on the type of material involved: bedrock, debris, earth. Falls are abrupt movements of masses of geologic materials that become detached from steep slopes or cliffs. Movement occurs by free fall, bouncing, or rolling. Depending on the type of earth materials involved, the result is a rock fall, soil fall, debris fall, earth fall, or boulder fall. All types of falls are promoted by undercutting, differential weathering, excavation, or stream erosion. A topple is a block of rock that tilts or rotates forward at a pivot or hinge point and then separates from the main mass, falling to the slope below, and subsequently bouncing or rolling down the slope. The 2 major types of slides are: translational slide, the mass moves out, or down and outward along a relatively planar surface and has little rotational movement or backward tilting. The mass commonly slides out on top of the original ground surface. Rotational slide is one in which the surface of rupture is curved concavely upward, spoon-shaped, and the slide movement is rotational about an axis that is parallel to the contour of the slope. A slump is an example of a small rotational slide. Lateral spreads are distinctive because they occur on very gentle slopes or flat terrain. The mode of movement is lateral extension accompanied by shear or tensile fractures. The failure is caused by liquefaction, the process whereby saturated, loose, cohesionless sediments, usually sands and silts, are transformed from a solid into a liquefied state. Failure is triggered by rapid ground motion, such as that experienced during an earthquake, but can also be artificially induced. The failure starts suddenly in a small area and spreads rapidly. The initial failure is a slump, but in some materials movement occurs for no apparent reason. The 5 basic categories of flows that differ in fundamental ways are: debris flow is a form of rapid mass movement in which a combination of loose soil, rock, organic matter, air, and water mobilize as a slurry that flows downslope. Debris flows are commonly caused by intense surface water flow, due to heavy precipitation or rapid snow melt, that erodes and mobilizes loose soil or rock on steep slopes. Debris avalanche is a variety of very rapid to extremely rapid debris flows. Earth flow has a characteristic hourglass shape. The slope material liquefies and runs out, forming a bowl or depression at the head. Mudflow is an earth flow consisting of material that is wet enough to flow rapidly and that contains at least 50% sand, silt, or clay-sized particles. Creep is the imperceptibly slow, steady, downward movement of slope-forming soil or rock. Movement is caused by shear stress sufficient to produce permanent deformation, but too small to produce shear failure. There are generally 3 types of creep. Seasonal, where movement is within the depth of soil affected by seasonal changes in soil moisture and soil temperature. Continuous, where shear stress continuously exceeds the strength of the material. Progressive, where slopes are reaching the point of failure as other types of mass movements. Creep is indicated by curved tree trunks, bent fences or retaining walls, tilted poles or fences, and small soil ripples or ridges. Long-term climatic changes can significantly impact soil stability. A general reduction in precipitation leads to a lowering of water table and reduction in overall weight of soil mass, reduced solution of materials and less powerful freeze-thaw activity. A significant upsurge in precipitation or ground saturation would dramatically increase the level of groundwater. When sloped areas are completely saturated with water, landslides can occur. If there is an absence of mechanical root support, the soils start to run off. Seismic activities have, for a long time, contributed to landslides across the globe. Any moment tectonic plates move, the soil covering them also moves. When earthquakes strike areas with steep slopes, on numerous occasions, the soil slips leading to landslides. In addition, ash and debris flows instigated by earthquakes could also cause mass soil movement. Weathering is the natural procedure of rock deterioration that leads to weak, landslide-susceptible materials. Weathering is brought about by the chemical action of water, air, plants, and bacteria. When the rocks are weak enough, they slip away causing landslides. Erosion caused by sporadic running water such as streams, rivers, wind, currents, ice, and waves wipes out latent and lateral slope support, enabling landslides to occur easily. Volcanic eruptions can trigger landslides. If an eruption occurs in a wet condition, the soil will start to move downhill, instigating a landslide. Stratovolcanoes are the most typical example of volcanoes responsible for landslides across the globe. Forest fires. Forest fires instigate soil erosion and bring about floods, which might lead to landslides. Gravity. Gravity provides the energy to displace the soil and bedrock, but other factors contribute to an increase in stress and decrease in strength. A stress tends to make part of a block material slide with respect to an adjoining part. Mining activities that utilize blasting techniques contribute mightily to landslides. Vibrations emanating from the blasts can weaken soils in other areas susceptible to landslides. The weakening of soil means a landslide can occur anytime. Clear cutting is a technique of timber harvesting that eliminates all old trees from an area. This technique is dangerous since it decimates the existing mechanical root structure of the area in which it is applied. A landslide dam or barrier lake is a natural damming of a river by certain kinds of landslides, such as debris flows and rock avalanches, or by volcanic eruptions. If the damming landslides are caused by an earthquake, it may also be called a quake lake. The water impounded by a landslide dam may create a dam reservoir, lake, that may last from short times to several thousand years. Because of their rather loose nature and absence of controlled spillway, landslide dams frequently fail catastrophically and lead to downstream flooding, often with high casualties. A common failure scenario is overflowing with subsequent dam breach and erosion by the overflow stream. Landslide dams are responsible for two types of flooding: backflooding, upstream flooding, upon creation, and downstream flooding upon failure. Compared with catastrophic downflooding, relative slow backflooding typically presents little life hazard, but property damage can be substantial. While the dam is being filled, the surrounding groundwater level rises. The dam failure may trigger further catastrophic processes. As the water level rapidly drops, the uncompensated groundwater hydraulic pressure may initiate additional landslides. Landslides that fall into the dam reservoir may lead to further catastrophic spillages. The resulting flood may undercut the sides of the river valley to further produce landslides downstream. After forming, the dam leads to a gradation of the valley upstream, and dam failure leads to a gradation downstream. Construction engineers responsible for design of artificial dams and other structures in river valleys must take into account the potential of such events leading to abrupt changes in a river's regimen. The effects of the landslides are divided at the following categories, which namely are: economic decline, decimation of infrastructure, loss of life, aesthetic degradation of landslides, impacts on river ecosystems. Landslides have been verified to result in destruction of property. If the landslide is significant, it could drain the economy of the region. After a landslide, the area affected normally undergoes rehabilitation. This rehabilitation involves massive capital outlay. For example, the 1983 landslide at Utah in the United States resulted in rehabilitation cost of about $500 million. The force flow of mud, debris, and rocks as a result of a landslide can cause serious damage to property. Infrastructures such as roads, railways, leisure destinations, buildings, and communication systems can be decimated by a single landslide. Communities living at the foot of hills and mountains are at a greater risk of death by landslides. A substantial landslide carries along huge rocks, heavy debris, and heavy soil with it. This kind of landslide has the capacity to kill a high number of people on impact. For instance, landslides in the UK caused the rotation of debris that destroyed a school and killed over 144 people, including 116 school children aged between 7 and 10 years. The erosion left behind by landslides results in rugged landscapes that are unsightly. The pile of soil, rock, and debris downhill can cover land utilized by the community for agricultural or social purposes. The soil, debris, and rocks sliding downhill can find their way into rivers and block their natural flow. Many river inhabitants like fish can die due to interference of natural flow of water. Communities depending on the river water for household activities and irrigation will suffer if flow of water is blocked. Landslide prevention methods are the following. Improving surface and subsurface drainage. Excavating the head. Buttressing the toe. Constructing piles and retaining walls. Removal and replacement of soil and rock. Preserving vegetation. Rock fall protection. As water is a main factor in landslides, improving surface and subsurface drainage at the site can increase the stability of a landslide-prone slope. Surface water should be diverted away from the landslide-prone region by channeling water in a lined drainage ditch or sewer pipe to the base of the slope. The water should be diverted in such a way as to avoid triggering a landslide adjacent to the site. Surface water should not be allowed to pond on the landslide-prone slope. Groundwater can be drained from the soil using trenches filled with gravel and perforated pipes or pumped water wells. Removing the soil and rock at the head of the landslide decreases the driving pressure and can slow or stop a landslide. Additional soil and rock above the landslide will need to be removed to prevent a new landslide from forming upslope. Flattening the slope angle at the top of the hill can help stabilize landslide-prone slopes. If the toe of the landslide is at the base of the slope, fill can be placed over the toe and along the base of the slope. The fill increases the resisting forces along the failure surface in the toe area. This, in turn, blocks the material in the head from moving toward the toe. If the toe is higher on the slope, adding fill would overload the soil and rock below the toe, thus causing a landslide to form downslope of the fill. Piles are metal beams that are either driven into the soil or placed in drill holes. Properly placed piles should extend into a competent rock layer below the landslide. Wooden beams and telephone poles are not recommended for use as piles because they lack strength and can rot. Because landslides can ooze through the gaps between the piles, retaining walls are often constructed. Retaining walls can be constructed by adding lagging, metal, concrete, or wooden beams, horizontally between the piles. Such walls can be further strengthened by adding tiebacks and buttressing beams. Tiebacks are long rods that are attached to the piles and to a competent rock layer below the ground surface. Buttressing beams are placed at an angle downslope of the piles to prevent the piles from toppling or tilting. Retaining walls also are constructed of concrete, cinder blocks, rock, railroad ties, or logs, but these may not be strong enough to resist landslide movement and could topple. Landslide-prone soil and rock can be removed and replaced with stronger materials, such as silty or sandy soils. Weathering of shales can form landslide-prone soils. The removal and replacement procedure must include measures to prevent the continued weathering of the remaining rock. Landslide material should never be pushed back up the slope. This would simply lead to continued motion of the landslide. Trees, grasses, and vegetation can minimize the amount of water infiltrating into the soil, slow the erosion caused by surface water flow, and remove water from the soil. Although vegetation alone cannot prevent or stop a landslide, removal of vegetation from a landslide-prone slope may initiate a landslide. Rock falls are contained by ditches at the base of the rock exposure, heavy-duty fences, concrete catch walls that slow errant boulders that have broken free from the rock outcrop. In some cases, loose blocks of rock are attached to bedrock with rock bolts, long metal rods that are anchored in competent bedrock and are threaded on the outside for large nuts. A metal plate with a center hole, like a very large washer, is placed over the end of the rod, where it extends from the loose block, and the nut is then added and tightened. Once constructed, remedial measures must be inspected and maintained. Lack of maintenance can cause renewed landslide movement.